Okay, welcome to this DCG video on the DEB Mock QB3 2025 exam. So we've got the plan and elevation of a similar structure to this house. We have to draw the given plan. It says nothing about the elevation. And make a perspective drawing of the structure given the following information. S is 18 meters from corner A. There's corner A there. Corner A. And the picture plane passes through corner A. The horizon line is 11 meters above the ground line, and the sloping roof surfaces are both at 25 degrees. So 25, okay, 25. Use auxiliary vanishing points where appropriate. So use your auxiliary vanishing points for the sloping surfaces. Part B, determine and indicate in meters, so that means find and tell them, alright, in meters the height of point P. So there's P in plan, there's P in elevation, there's P in 3D. So I'm just going to start and show you a model of this before we draw the plan. Okay, so we'll just have a quick look of the model. So that's the solid there. We're going to draw the plan view of it there. So scale is 1 is to 200. Everything's in meters, so convert meters to millimeters. So for example, 16 meters, 16,000. Divide by 200, so knock off 2 noughts. Okay, so then you have 2 into 160, then you get 80. Alright, so a quick thing to do is divide every number by 2, add a 0 to make your life easier. Alright. Okay, well, 13 is the more complicated one. 6.55 centimeters or 65 millimeters, 40 millimeters, 10 millimeters, 80. Now we'll draw our plan. So we're going 80 millimeters across here for the total width. Okay, from our start point. Alright, sorry, I was a little bit out there. So from our start point 50, and then 65. Okay, I can heavy from the 10 to the 50 mil mark. Okay, and then it's 80 again. And halfway for a center line down to 2 centimeters or 20 millimeters and up to and sorry, that should be hidden detail. So I'm going to pause that. Then we can bring these across. So that's our roof in plan. Okay, here's a little canopy, a little smaller roof, kind of like a porch. Then there's some hidden detail there. There we go. Now, I'm now going to show you how to find a spectator, okay, how to get the picture plane, how to get the vanishing points, the horizon line, and the ground line. So, spectator, picture plane, vanishing points, horizon line, ground line. I'll quickly show you that in 3D. spectator, picture plane, horizon line and ground line, and the vanishing points. Right, so in the question, the spectator In the question, the spectator is 40 degrees from corner A, 18 meters, so after the scale 90 millimeters. Don't put corner A anywhere else. That's a common mistake students do. So we've located corner A in plan. Light line there. We get our protractor. Right, and we're going to measure 40 degrees. So we're going to draw a line along that. And then we're going to measure 90 millimeters on that line. And this will be where the spectator is. So that's the spectator in plan. Now, we're going to join the spectator to the two outermost corners of our plan view. And we're going to find the center line of the spectator's vision. So we're joining the spectator to outermost corners. We're going to get our compass. We're going to set our compass to any radius. We're going to swing an arc to touch those two lines. I'm going to lift our compass, same radius, and we're going to swing again. Now, here is the spectator's or center line of vision, the bisector of the angle. So we have that drawn in, and our picture plane is going to be at a right angle to that. So I've got my adjustable set square, lined it up with the center line of vision, okay, and the picture plane is going to be at a right angle, okay, through corner A. There, that's the picture plane in plan. Now you can use, alright, your sliding set squares if you want, okay, to do it either. So you can, where's the other set square? So you can line up your set squares like this, slide it down, and then here's it either. Right now, so our horizon line can be drawn anywhere after S. So we're going to draw in our horizon line. Our ground line has to be, okay, 55 millimeters from our horizon line, because it says 11 meters, so divide that scale once to 200 and you get 55. So we're going to mark 55. We're going to draw in our ground line. So here's our ground line. Horizon line. Picture plane. Now, how do we get our vanishing points on that? So how do we get our vanishing points? Well, we're going to go parallel to the sides of the object, okay, from the spectator in plan. So look, this red line is parallel with this set of sides or parallel lines. This red line is parallel with this set of parallel lines. So from the spectator, look, these are parallel lines. I'm going parallel from S to them to touch the picture plane. There's VP1. I'm going parallel to these lines from S as well. There's VP2. Then we're going to bring them down perpendicular to the picture plane to touch vanishing, or the horizon line. So there's VP1 on the horizon line, and there's VP2 on the horizon line. So now we're going to target setting up our perspective drawing. So, okay, to do our perspective drawing, we're going to label these points, okay, all these points in the object in plan and elevation on our question sheet, and we're going to join all the points to the spectator, okay, which results, okay, these green lines, we're going to join them all to the spectator. Right, so let's label these. Right, A/E, F/B, D/C, okay, and there's P, right? There you can see what they're going to result in 3D, A, E, F, B, C, D. Now, we're going to join all the points in plan to the spectator. Where these points join to the spectator, pierce the picture plane, they result in the perspective image. Look. Right. See, where the green lines pierce the picture plane, you get points on the perspective image. So we're going to join all the points to the spectator, even if we're not going to use them all. Now, you don't have to draw the line the whole way to S. Look, so I could do it if I wanted it, but you can stop when it touches the picture plane. Now, that's that done. The next thing I'm going to do is all those points on the picture plane, I'm going to draw them down perpendicular to the picture plane. So all of them there I'm going to bring down perpendicular to the picture plane, regardless of whether we will use them or not. What it actually means is you're rotating the perspective image, okay, onto the horizontal plane so you can see it. So we're just going to, where they all intersect the picture plane, we're going down at 90 degrees to the picture plane, so parallel to the center line of vision. And to keep it simple, we're going to stop at the ground line. Now, so we're going to start some of our perspective draw. Alright, so from the base of any point on the picture plane in plan is the true height in the perspective image. Okay, and the base of the line in the perspective image is going to be on the ground. So we're going to bring A right down to touch the ground line. And we're going to join back to VP1 and VP2. So we already have A down to the ground line. So we're going to join to VP1 and VP2. And the base of this here in the perspective drawn is going to be on that line. So B and C are going to be on the line. So I'm going to drop B. So join to S where it hits the picture plane down perpendicular to touch that line. Here's point B. Okay, C I do the same way. I forgot to bring C down earlier. So where it intersects the picture plane, we're bringing that down perpendicular. There's point C. Now we can join them together. So B to C can be heavied in together, and I can join it B to vanishing point 2, because the line's going this way, I'm going to VP2, the line's going this way, I'm going to VP1. Now, let's get point D. D has a true height of 16 meters, 80 millimeters. Any point on the picture plane, okay, in plan is the true height. A is on the picture plane, so we're going to apply the true height of 80 millimeters here, and we're going to join to VP1. So 80 there, and join to VP1. And when it intersects the line coming down from D, that's when we get the altitude of D. So from the line coming from A, we're going to mark the true height of 80 millimeters in the perspective drawn, and we're going to join to VP1, and when it crosses the line coming down from C, that's point D, and we can heavy together there. So look, that there is the same, that point there is the same height as this one here. So if I were to do a 3D sketch, and if I were to say these were parallel, okay, I'm going to prove a different way. Sorry, I actually picked the wrong point. I didn't mean to pick from there. It's actually on this one coming down from corner A. So that's it there. Okay, and that's it there. And they are the same height from that symbol there. So true heights can be applied along a point on the picture plane. Now, so we have point D, right? If we want to continue this, let's do the slope and surface. So A to D is 25 degrees. It's going to use an auxiliary vanishing point. So we need this construction here of getting an auxiliary vanishing point and putting it under VP1. So what is it in the actual sheet? So this is auxiliary or sloping lines use an additional vanishing point, okay, that is underneath the ordinary vanishing point for horizontal lines. Here's the triangle connecting the 3 points together, so the V vanishing point, auxiliary vanishing point, and the spectator. That line is always parallel to the slope of the roof. This is the true height between them, and that is what we need to complete our perspective drawn. So what we're really doing is rotating this in plan to see the true shape. So the key bits of information here is that the angle is 25 degrees. This is the sloping line. The vanishing point that this would use if it was horizontal will be VP1. So the auxiliary vanishing point will be underneath that one. So we're going to get our protractor and we're going to go 25 degrees to line S to VP1 from letter S. So carefully you don't mark 15 or 35. Okay, it's 25 there. So carefully you don't mark 15. So we're going to mark in the angle, or mark in the 25 degree line here. We have to go to right angle to line S to VP1. So we have to go to right angle, which is just coincidentally straight down in this, has to be a right angle. Now, this is the auxiliary vanishing point. And this is the true height. So we're going to take that distance with our compass. So we'll take that distance with our compass. And we're going to put that below VP1. And I'm going to put it above VP1 as well, because I know I'll need it later. So I put it below VP1. You probably couldn't see that little bit there. I'll just move the visualizer. So we put it below VP1 and above VP1. So look, this was the distance we took. Put it above VP1, below VP1. Alright, and then we're going to draw these together. Or we're going to draw in a line through these. We're going to connect them, one of these through D. Now, so auxiliary VP 1 AUX VP. All these 3 points, or this whole line, appears as a point in plan, AUX VP. So I'm going to draw this line through point D. Now, where it hits the line coming down from A, the perpendicular line, okay, that's point A. Right, there's point D. The vertical distance between A and E is 2 meters in real life. It's on the picture plane in plan, so it's a true height in the perspective image. So after we do our scale, it's 10 millimeters, so we can just drop down 10. That's point E. Now, sloping lines join to the auxiliary vanishing point. So I can join that to the auxiliary vanishing point there. Now I can heavy in this line to touch the one coming down from B. There's point F, and we can join that to B. Now, these lines are going off to VP2, so I can join them to VP2. So A to VP2, E to VP2, F to VP2, B to VP2. Right, we're going to add in some, or mark in some additional points here. So G and H. This is G slash H in plan. Okay, I and J. There's I slash J. Right, to get G, look, we're going to join to S, where it hits the picture plane down perpendicular to touch the line from A. There's H. We can heavy them in. Now, point H is on the sloping part of the roof. So there's point H. So there's point H. So we can join H to the auxiliary vanishing point because it's the sloping line. So I'm going to join H to the auxiliary vanishing point down here. Okay, we can find the line I by when I hits the picture plane down perpendicular, and we can stop it there when it touches that line there going to the sloping auxiliary vanishing point where they intersect. That's point I. Okay, point J, if we bring it down further, that's point J. We can join them together. Now, we're going to target the sloping surface at the front, or the little canopy. So, this one. So, we're going to label in our points. K slash L. Okay, Q slash P. Okay, and R slash, I don't have anything there, QP, or slash S. So in plan view then, K slash R, okay, Q, P, and L slash S. Now, K has a height, okay, or a true height of 80 millimeters or 16 meters. So we mark 80 along there. Where that hits this line, F to B, we can join to vanishing point 2. So this is its true height in perspective. Where the line coming from, or where the line that comes from K to the spectator hits the picture plane, we can bring that down perpendicular to touch that line there. Now that's point K. We'll get R soon. For L, we can do the same. We can bring L where it touches the picture plane, we can bring L down to touch that there. So there's point L. So we can join them together. Now, these are sloping lines as well. Okay, so they're going to use an auxiliary vanishing point, but this time it's just above the ordinary vanishing point because it's sloping upwards. So you can see the face sloping upwards, so this vanishing point up there. So I'm going to draw a line from the auxiliary vanishing point up there through point K and through point L. Now, Q and P are on those sloping lines. So where P touches the picture plane down perpendicular, that's point P. Okay, where Q joined to the spectator hits the picture plane down perpendicular, that's point Q. So we can join these together. It's no coincidence that when you join Q and P, okay, you're going to touch the vanishing point 2 there. No coincidence. Now, we just need points R and S. Okay, to get points R and S, right? So Q to R, here's Q to R. That joins to VP1. So I can join Q to VP1. Alright, I can go down perpendicular from the picture plane where point R touches it. And that's point R. So I can heavy them in. So I can join back now. R to S goes to VP2. So I can join that back to VP2. Where the line, okay, coming from this here touches the picture plane. That's point S. And it's no coincidence that them joined together would touch at VP1. Now, then we have this detail here. We can heavy that in. Now, next thing we have to do is determine the true height of point P. So any point on the picture plane is the true height. So what we're going to do is we're going to put a plane through point P, and where that touches the picture plane, it's going to give us the true height of it. Alright, so it's going to give us the true height of P by extending that line in to touch it. So how this works in perspective, we're going to extend this line here. This line would ordinarily go to, or this line would go to VP1 in the perspective image. So where it hits the picture plane, we're going to bring this down. Then we're going to go from VP1 through point P to touch that. Here's our true height. 66, and when you multiply 66 by 200, you'll get 13.2 meters. Right, thank you very much. You can like and subscribe for more videos, or drop a comment or drop a message in the comments for a video you want. Thank you.